So the first thing we're going to do is we're going to, yeah, Sienna.
Why do you need exact triangles?
You'll see. We're going to be measuring them, and so I wanted them to be exact so we all get the same measurements. Okay, so we're going to first write the triangle sum theorem down. I think you guys already know this theorem, but you've never had it formally stated like this. So the triangle sum theorem it states that the sum of the measures of the interior angles of a triangle is 180 degrees. Okay. Now, when it talks about interior angles, that's the angles on the inside of the triangle. And tomorrow we're going to be talking about exterior angles of a triangle, but for today we're just going to talk about the angles inside. You guys probably already know that. You guys already know that all the angles inside of a triangle add to 180. Probably. And if you don't, that's fine too. We're going to do that today. So what we're going to do here is we're first going to classify the triangles, and then we're going to find the length or the measure of the missing angle for each triangle. So our example here says classify each triangle and find the missing, what's that, Maddie?
When you give a definition for triangle sum theorem, did you put just shape of a triangle with the measures? Because it says states that the sum of the measures.
The measures of the interior angles. No, that's correct. Yeah, it may sound a little strange, but that's what it's supposed to say. It's trying to be really exact so that you know, like it's proper. So it states that the theorem states that the sum of the measures of the angles. So when you add up all the measures of all the angles, the interior angles, that it adds to 180. Okay, so let's take a look at this first triangle here. Any triangle that has a right angle, like this one does, is considered a right triangle. Okay. So this one right here is a right triangle. Now, we're going to find the missing angle. Well, all these interior angles of a triangle add up to 180, okay? So that means you have this angle right here, which is 90 degrees. So you have 90 degrees plus 50 degrees. And then we'll just call this angle X for now until we find out what the measure is of this angle. And it all adds up to 180 degrees, okay? So if we simplify this, and if we solve for X, we're gonna find that X is equal to 40 degrees. Makes sense so far, right? Awesome. Okay, let's take a look at the next triangle here. Anytime you have an angle in your triangle that is greater than 90 degrees, we would call this an obtuse triangle. An obtuse triangle is a triangle, oh goodness, I need some white out already. An obtuse triangle is a triangle that has one angle that is greater than 90 degrees, or just basically one angle that's obtuse. If there's one angle that's obtuse, it's an obtuse triangle. Okay, so I'm going to go ahead and add up all of these angles here. We'll call this x again. So this is going to be 25 degrees, 112 degrees, and x degrees. And because of this triangle sum theorem, we know that the sum of all of these angles is 180. And we use that fact to find the measure of our angle. Okay, so this is going to be 137. Okay, I subtract 137 from both sides, and we get that x is equal to 43 degrees. So the measure of this missing angle here is 43 degrees. Can anyone guess what this last triangle is called? Green. Acute. Acute triangles are the cutest ones. So dainty, right? All right. So this triangle is an acute triangle. Okay. And an acute triangle has all the angles under 90 degrees. Okay, so all the angles are going to be less than 90 for an acute triangle. And if we want to find our missing angle, we're just going to add these all up. So this will be 50 degrees plus 70 degrees plus x degrees is equal to 180. So this is 120. Subtract 120 from both sides, and then you get x is equal to 60 degrees. So this angle right here is 60 degrees. So that's the triangle sum theorem. It's very straightforward, okay? So what we're going to do now, though, is we're going to start comparing the lengths of the sides to the angles that are opposite of them. Okay, so everyone's going to need a ruler. So if you have a ruler, take it out. If you don't have a ruler, I'll come give you one in just a second. But what we're going to do is we're going to measure and label the lengths of each side of each triangle. Okay, so I'm going to come around, pass out rulers. Millimeters to measure the sides of each triangle, and I'll show you what I mean. I want it to be really exact, so that's why we're doing millimeters. Now, millimeters, if you look at your ruler here, you're going to see centimeters. Millimeters are the little tick marks in between. So 1 centimeter is 10 millimeters. So when I measure this side, I'm getting about 55 millimeters. Now I should warn you that half of you have this printed from one printer and half of you have it printed from another printer. I think they're the same size, but I don't know. So your measurements might be slightly off from mine if you have one that's from the different printer. Okay. Now if I measure here, that looks like it's about 34 millimeters. And then I'm gonna measure this last side of this triangle. That looks like a 45 millimeters. Okay, so go through and measure the sides of the other two triangles. I should have him facing you guys so he's like watching you. I'm watching you. It's like a little dragon. Gianna Kimpeck is really good at origami, and she made that for my birthday. She also folded this paper into a little box, and she folded tiny little stars. Yeah, I know, they're amazing. Look at them. They're three-dimensional stars.
Are you able to put it under the?
Yeah. See? Aren't they cool? Because I taught flight and space. She was in my flight and space class, so that was her like little thank you gift, is little stars. And I'm like, they're so cool. She's really gifted. She like watches YouTube videos and stuff to see how to fold paper. Do origami. So this is my birthday dragon that will forever be watching you. Okay, once you have measured all the sides, I'm actually going to have you answer a question on the back, and then we're going to discuss it. Okay, so my question is, what do you notice about the side lengths and the angles opposite those sides? Okay, so that's my question. In other words, if I have an angle like this, what do you notice about the angle and the length of the side across from it? Okay, so take a look at all the measurements that you made on the other side, look at the angle measures, and see if you notice anything about this. I'm gonna flip this so we can look at those triangles again and talk about it. Does anyone want to share what they noticed about the relationship between the angle and the side length? Sean.
Like the biggest angle will always be opposite the biggest side, and smallest angle will always be opposite the small side. Like in a right triangle, how the hypotenuse is always opposite the right angle.
Yeah, the hypotenuse is always opposite the right angle and it's always the largest. Because in a right triangle, that right angle will always be the largest, right? How many of you had that thought too? No? Okay, let's take a look at what Ishan said, because he's right on the money here. This angle right here is the largest angle in this triangle. It's always going to be opposite the line that is the longest. Okay? So if this angle is the largest, the line that's opposite of it will also be the longest. And this angle is the smallest, right? So this line right here is the shortest. Wait, what? Let's take a look at this one right here. Okay? The largest angle is right here, 90 degrees.
Okay.
The side that is opposite of it, since this is the largest angle, this is going to be the longest side. And the smallest angle is 40. 40 is opposite this side right here, which is the shortest side. Yeah, pretty.
But what about the last one? How would you put that pattern?
So the last one right here, the largest angle is 70. And I imagine when you measured it, this side length that's opposite of 70 is probably the longest side length, right?
I would get it wrong then because both of these sides do the same.
Oh yeah, you probably did. And the shortest side length would be across the 50-degree angle because it's the smallest angle measured. Okay. So I already know number 1 on your homework. I really want you to toil with it and see if you can figure out the measure of all the angles. But if you don't get it, we'll go over it tomorrow. Okay? So just try every problem and see if you can get it. And we'll go over it.
6, 5,
Problems digitally. So that's why, just take a gander between classes during nutrition break. Just take a look at them.
Are there questions like where